In today class, we are going to discuss the different type of material conventions which were used in engineering graphics. Okay, different type of materials will be represented in different conventions. First, we'll start with the metals. For the metals, we have a two type of conventions. The first one is in a rectangle box, we're going to use the inclined lines, the one-sided inclined lines. This represents the steel, cast iron, and aluminum alloys and the cast iron alloys type of metals can be represented over here. And second one is double inclined lines either side from left to right and right to left. This kind of representation will be shows the lead, zinc, tin, and white metal kind of metals will be represented by using this convention. And the glass kind of metals will be represented like this in a rectangular box. We have a pattern like this. The middle line will be bigger, and either side the keep on size of the line will keep on reduces. That such kind of representation will be used for glass. And the packing and insulating materials will be like this. Here, the inclined lines with the dashed lines will be representing the materials like porcelain, stoneware, marble, slate, etc. And second one is horizontal line with one-sided inclined lines. This will represent the asbestos, fiber, cork, rubber, leather, wax insulating materials. Such materials will be represented like this. Next, liquid kind of materials will be represented on your off-filled dashed lines with horizontal dashed lines will be used to show the liquid. Liquid means like water, petrol, kerosene, etc. etc. And the wood kind of things will be like just like a spider web kind of structure will be shown here. So this will represent the wood or polywood. In last concrete will be in a rectangular box filled with the dot lines, and randomly is rectangle filled rectangles will be shown irregular pattern. So that will show the concrete. This is what the different material conventions were used in engineering drawing. Okay, next coming to the dimensioning. The dimensioning is the most important in engineering graphics. All the information what we do or what we want to show, the dimensioning will be properly done. So the dimensioning is art of showing the various sizes or measurements in a drawing of an object in a drawing sheet. So here the type of dimensioning we can classify mainly on size or functional dimensioning, and second one is location or datum dimensioning. For size or functional dimensioning means it gives the it shows the measurement of an object. For example, if you want to show the length of this line, so that is the size dimension. For example, see, this is the length of the line. It can be shown as size or functional dimension will be shown, and the diameter is shown. So diameter of that is called as size or functional dimension. Coming to the location or datum, here what happens? The position of an object with respect to a one reference. With one reference, we are giving a position of an object where it is located. Such kind of the dimension is called as location or datum dimension. See here, the center of the circle is having a distance of L from the side wall or this edge. So that indicates the position of the center with respect to this side or this edge. So this is called as location or datum. See over here also, the center is having from side edge having a distance L, and from the bottom edge having distance L. These are the two kind of dimension will be used. Next, notations of dimensioning. What are the main notations of dimensioning? If you take an object, if a drawing of an object like this, so if you want to show the dimensioning, what are the main elements comes? The first comes with the extension lines. These are the extension lines. This is the first extension lines will be drawn at the end of the line where we want to measure, which we want to measure the dimension. So I want to check the entire length of this line. Means now at the end of this line, I need to draw an extension line. The line should perpendicular to this line, and it should not touch the main object or main drawing. It should not touch the main drawing, and it should have some distance, and it should be drawn always perpendicular to it. and the two ends between the entities we need to write these two lines. And next, after drawing these extension lines, next one is the dimension line. Next line we need to draw is dimension line. The dimension line is drawn between these two extension lines, and it should not start at the end of the extension line. We need to leave some space, 2 to 3 mm we need to leave the space, and then we need to draw this dimension line. This dimension line is always parallel to the line which we want to show the dimension, or you can say it should be perpendicular to extension line. Okay, that is the dimension line. After dimension line, at the almost middle or center or on the top of this dimension line, we will write the dimension figure. This dimension figure shows the quantity of quantity of measurement. That means this line is having 90 mm. So that is what dimension figure. These are the main elements. Along with that, at the end of this dimension line, we need to terminate the dimension line with the arrowheads. So arrowheads are shown at the end of this dimension line. The arrowhead should be follow the dimension or the size pattern is 1:3. That means the width of the dimension, if you take 1, then the length of this arrowhead should be 3. 3 means, for example, here x, and this should be 3x. If you take 1 and this should be 3, 1 mm means here the length should be 3 mm. That is 1:3 ratio we need to follow when we drawing the arrowheads. This is one kind. Next one is we can use the leaders also. Leaders will be used in write the notes, kind of such kind of things. We can use the leaders. Leaders may be having 30 degree, 45 degree, 60 degree angle. This is the inclined line, which for example I am showing the information, the note I am writing for the circle. That means here this is what 2 holes having the same dimension, 2 holes of diameter 12. So we can use the symbols to show the information of this one. The 5 will be shown for the diameter of the circle. Like this, we can, to write the notes, we can use the leaders to show it in the drawing. These are the main notations in the dimension. The same we can have the blackboard explanation, that also we can see here.
Okay. So notation of dimensioning. So what are the notation of dimensioning we will follow in here? If you want to dimension any object or any drawing, we need to follow the rules over here. The first, after drawing the sketch should be visible line. And first we will draw the extension line. The extension line means the line which will show the, if you want to measure distance between the two ends. So there we need to draw these extension lines. That extension line should be always perpendicular to which we want to show the dimension. For example, I want to show the length of this line. So then I need to write the dimension line either end of this line, and the dimension line should be perpendicular to this, and it should not touch the main drawing. So leave some space here. From here we need to draw extension line perpendicular to this, and another end also we need to draw these extension lines. And these two extension lines should be perpendicular to the line which we want to show the dimension. After writing this extension line, and then we need to draw the dimension line. The dimension line should be parallel to the line which we want to measure it. So it should be parallel. Dimension line should be parallel to this, and the dimension line you should not draw at the end of the extension lines. It should be have the 3 mm space, and it should be parallel to the main. The line which you want to measure, for that the dimension line should be parallel to that. Okay. Next, after dimension line, at the end of the dimension line should be terminated with the arrow edge. That means arrow edge should be drawn like this. The arrow edge should be at the end of this dimension line. Okay. While writing the arrow edge, we need to follow 3:1. That means if you take the arrow edge, if you consider this is the x, and the length should be 3x. The width of the arrow edge and length ratio should be 1:3. The length should be always 3 times bigger than the width. Like this, we need to follow the arrow edge. After writing the arrow edge, the dimension figure. The dimension figure means it is the quantity, how much quantity it is, the length it is there. For example, if this is 100 mm. So we need to write it. Two methods is there. One is over the at the almost at the middle of the dimension line. We can write over the dimension line, and no need to write any prefix or here. That is millimeter abbreviations. We should not write millimeter or centimeter. Nothing. The common dimension should be followed. That is all the dimensions in mm. That we can write it somewhere on the corner of the page. We need to follow it. One is on the top of the dimension line, or else in between dimension line. Like this also we can write the dimension figure.
Okay, this is the explanation of the dimension line. Go with the one sentence explanation. A thin continuous line used to indicate the measurement. Then extension line, thin continuous line extending behind the outline of the object. Then arrowheads used to terminate the dimension lines. The length and width ratio will be 3:1. Space is filled up, means the arrow should be filled. Then note, give the information regarding specific operations related to a feature. Then leader, the thin continuous line connecting to node of a dimension figure which the feature to be which applied terminated by arrowhead or dot. These dimension lines in that with leader line can be, see at the end it should be either arrowheads we can use it or we can use the dot. Then symbols represent any objects by some mark on the drawing. So these are the explanations of it. Next, units of dimension. So normally units will be we use commonly millimeter the units, and whenever we do the dimension figure, that all that abbreviations will be not be shown like millimeter, centimeter, and all, because common dimension will be followed, and at the end of the means near the title box we'll write it all the dimensions or in inches or millimeters or centimeters, like that we need to write the message near the title box. The different ways of placing dimension in series. What are different varieties we have? The first one is chain type. The chain type, for example, this is an drawing. In that, how we will going to do. In a chain type of things, the dimension line will be in line, or it is a continuous line, will be used to show the dimensions of the different edges. Like this, it will be continuously, the dimension line will be drawn, and it is will be separated by these extension lines, and we will going to show the dimension. This is what chain type. And then parallel type. In the parallel type, we will going to set one particular reference, and from that reference we are going to measure each of the length with respect to this reference. Like this, see, this is the edge 20, and 20 plus 15 we will going to give the distance from the this edge side edge to this one, and same way then add 25 to this, then 60. This is what parallel type of dimension. Next category is combined. In this combined means here we use parallel as well as chain. Both the combination will going to use it. Then it will be combined type of dimension. And next one is progressive. In this progressive, what we'll do, we'll fix the datum. With respect to datum, we're going to measure all the dimensions. For example, in this case, we'll set this one as a datum 0. Then from this point, we're going to give the dimension progressively. This is 30, then 45. From this point, it is 45. Then from this point, it is 60. And either side also, it is 15 and 30 with respect to this datum. That is what the progressive type of dimension. You can check it out. Chain dimension means here arranged in straight line. Dimensions are arranged in straight line. and parallel dimension is all the dimensions are shown from common baseline and smaller dimension will be started first. Then combined in the year, the chain and parallel both will be combined and we can use simultaneously. And progressive dimension means if one datum or surface is selected, which is read as 0, the datum will be set, and all the dimensions are referred to that point or the surface. This is what the different ways of dimensioning series. The next one is here the dimension type comes here aligned system and unidirectional system. What is meant by aligned system and what is unidirectional? Once we write the dimension, we need to write the dimension figure. So here dimension figure, how we will represent the dimension figure, here the matrix aligned and unidirectional. In aligned system, so what happens irrespective of the dimension line, so all the dimension figure is written perpendicular to this dimension line. That is, you can see in it is always in line. Whether it is dimension is horizontal, it is like this, or vertical, it should be in line or it should be perpendicular. You can say perpendicular or in line with this dimension line. This is what the aligned system. See, this is your dimension line is vertical. It is kept like this. The dimension figure can be written two way. One is on the top of this dimension line, or in between we can erase some portion and we can insert the dimension figure between the at the center of this dimension line. Like this we can represent the aligned type of system. And coming to the unidirectional, in the unidirectional means irrespective of the dimension lines, all this dimension figure is kept in a one direction. That is, it is kept in horizontal. With respect to the bottom, it is kept in horizontal way. See all the here horizontal, it is kept in horizontal way, and in vertical, this dimension figure kept at horizontal. So like this, irrespective of the dimension line, the dimension figure is kept one angle, that is horizontal. We're going to keep it. So that is what the unidirection. You can see here also example. See, this is aligned system. See, irrespective of the inclination, all the dimension figures are in line or perpendicular to the dimension line. But in unidirectional, here although irrespective of these dimension lines, all the dimension figures are kept one direction, that is horizontal. So this is what two type of system, that is unidirectional system and aligned type of system. Some important rules for dimensioning. The first one is all the dimensions necessary for correct functioning of the part should be expressed directly on the drawing. Means all the dimensions should be drawn, no information should be skipped. Every dimension should be given, but none should be given more than once. This is the most important. Okay, means whatever the dimension be given, it is important, but same for the same edge, we should not give the multiple dimensioning for the same um, for the same area. We should not give the multiple information. That is what we should follow. One time information should be given. One dimension is enough. Next, a dimension should be placed on the view where its use is shown more clearly. That means the dimension should be placed. It should be clearly. It should not overlap and it should not be in congested area like that. It should be clearly visible. In such a manner, we need to write it. The extension line should be extended by about 3 mm beyond the dimension line. That is what I said. Dimension line should not be start at the end of the extension line. We need to give some 3 mm space. In aligned system of dimension is recommended. So most of the cases, aligned type of dimensioning is recommended, and we will use that also. Next, an outline or center line should never be used as a dimension line. A center line may be extended to serve an extension line. In dimension line, always we use the continuous thin line, but the center lines or outlines, the visible line should not be used. Mutual crossing of dimension lines and dimensioning between hidden lines should be avoided. Also, it should not cross any other lines of the drawing. Means whenever we do dimensioning, The dimension line should not be crossed between us. Means we need to avoid like that. We need to give the dimension. The inclined way edges comes there. In that cases, we should plan it properly and we need to keep it. It should not overlap. The multiple edges are there. Means in those cases, we need to properly plan it and we should write it without overwriting or overcrossing. Dimension should be placed outside the view, means as far as possible. Means we need to try to keep all the information uh, outside the main object. So that is what we need to maintain. The dimension lines should be drawn at least 8 mm away from the outline of each other. The dimension line what we draw parallel, no, that should be minimum 8 mm at least we need to maintain. In most of the cases we'll maintain. If it is not possible, we will try to fix it within that. But always try to make it at least minimum 8 mm gap. Next, in some special cases, when the things are real life, we don't have space to show the arrowheads. In that case, we can show the arrowheads outside and towards the dimension figure. We can write the arrowheads. Always, what we do arrowheads outside by showing outside. But in this case, we can see we can show in this way also. We can show the arrowheads towards the dimension figure like this also. If we don't have space to write the dimension figure in this, we can write the dimension figure outside also. And in common dimension having the same quantity, we can write it by showing the arrow heads and we can show it the common distance here also. We can represent it in this way also. And in some cases we can show the dots instead of arrowheads, we can show the dots. And in multiple dimension chain type, we can avoid the arrowheads and we can skip the arrowheads and we can show like this. These are the one in some these special cases we can use the dimensioning like this. And next for the dimension for the uh, diameters of a circle, we can use it like this. One is by showing the outside, we can use the arrowheads towards the center, and we can use a leader and we can show the dimensioning. And this one is we can draw the tangent to the circle and we can show the dimensioning, and we can write the dimension line inside and showing the arrow outside, and we can show the leader. And directly we can at the inside we can draw the dimension line passing through the center and we can write the dimension figure over there. Next, arc or radius, or we can show the radius uh, circle arc of a circle point, or we can show it here. So one is from the center, we can draw the arrowhead towards the outside and we can use the leader. And directly from the center, we can draw the one arrow-headed dimension line and we can write it the dimension figure. Or inside, we can just draw a dimension line and outside, we can use the leader to show it. These are the three methods we can use it for show the radius. Next, for spheres, the spheres we can show it like this, and the square columns we can show the information like this by writing the dimension figure. Inside or outside we can write it. And for angular dimensions, incline the edges between the two edges, we can show the arrowheads in towards the inclinations, and we can write the dimension figure outside, or we can write the dimension figure inside. If the space is big between the edges, we can show the dimension line with the curve, and it should be showing towards the edges. We can write and we can show the dimension figure like this. Here, length of the card can be shown like this, and length of the arc can be shown with the in arc type of dimension line. We can use it. These are the different ways we can use it to show the dimension.